For the following waveform, we're given the Fourier series. The Fourier series for this waveform we have using the Alternative Trigonometric Form, which is this right here. So we realized that the trigonometric waveform that we have right here has a period from 0 to approximately 40. And at, let's say, 20 right here, I think it is, we have even symmetry. Because if we were to take the whole left side and rotate it around the specific part, we would get the same thing on this other side. So we have even symmetry, and so we would use these down here to find our AV, our AN, and our B of n. Now, when we need to find the actual values, A1, A2, A3, A4, A5, it's good to make a chart like this, where we have n. This is the n that we're going to plug in. We have our A of n, which is what we're going to get out, and then we have our theta n. Now, the A of n right here, it's different from this A of n, like this right here. The A of n, how we would find it if we had multiple parts, is that we would set our A of n equal to the square root of our AN squared plus our BN squared. But since we don't have a BN, we're going to say that our A of n is equal to just our A of n, right? Because the squared and the square root are going to cancel out. The average value of our AV, we know, is this right here, right? So we have this as our AV, and so when we look at our given, we see that 25 is our AV, so we have 25 volts. And if we wanted to, we could use this and find the AV itself, but it's not necessary for here. So now let's find our different A of n's. What we can do is say, well, we know that this is our A of n right here, right? So this is going to be in our A of n, and this is going to be in our A of n. And so it's going to look like this. When we have 1, like how we have right here, we're going to have the decimal value of 45. So in here we can come and go write 45 for our A of n. Now we also need to know our angle. And so I didn't write this out, but our angle is equal to the basic tangent -1 of Bn over our A of n. Well, since B of n is equal to 0 for all of these, if we were to just plug this into a calculator once, we would see that all of our degrees are 0. And that's because the tangent -1 of 0 is just 0. So we have 45, 0, and now we need to plug in the next thing. So the next thing we would plug in is just replace this with 2. And so this is going to give us approximately 32. So we'll write 32 volts in here. And then we can do this again, where we replace this with 3. And this is going to give us approximately 15. So we plug that in there. And then we would plug in 4. So you would change this to 4. And then we would get 0 if we put in 5. But that should be a 4. And then we're going to get a -9. So these are all of our values here. And then we could just fill out this table right here. But I guess that's unnecessary because we fill it out here. But for future reference, if we didn't have all of this written out for us, if we weren't doing it on like a software, then writing out this table by hand would be pretty good to use to organize all of our work. So that's how you look about this problem or anything like it.